Okay, so I was just sitting here, and this idea popped in my head. Uh, like how could I adapt or apply the principle of cumulative acceleration to where I could use it to lift off from the planet Earth instead of only in space. Like, how do I bring the properties of space down to around my vessel so that I can use the principle of cumulative acceleration to launch from the planet? How do I apply the principle on a planet? And now on the moon, I know that I can do it because it has such low gravity and no atmosphere. And so on the moon, I know that I could ramp out using cumulative acceleration. And so what's really cool about the moon now is the fact that it's got no atmosphere. So this is one of the properties of space that allows me to use cumulative acceleration, right? Is the vacuum. So the total vacuum allows me to only have to push against the 0.16 gravity. You know what I mean? So I mean, it's just like you put your old science classes, they put a feather and a stone in a vacuum tube, and they create the vacuum in there, and then they say which one's going to fall first. They turn it over, and the feather and the stone fall at the same speed. Okay? So what I was thinking is, how do we create that vacuum in front of our vessels on the planet Earth? Because then that would totally reduce all the air friction problems that we have. So what is the method for creating a vacuum? And so what a vacuum is the absence of all the molecules that are in front of us. So we have to push them out of the way somehow and create that sort of vacuum, and it has to be sort of an electromagnetic bubble that extends out in front of our vessel, right? And pushes out because it has to be a continuous pushing, or else all the wind will suck back in. You know what I mean? But if we can create an electromagnetic bubble in front of our airplane, or our shuttle, or a rocket, if we can create that like a bubble that somehow pushes all of the chemical atoms away and creates a vacuum, then first of all, there's no air resistance. And second of all, we are only, when it's a rocket, we're only fighting against the 1G. So, in electromagnetics, because atoms and things have charges, you're going to be able to push them away with electromagnetics. You know what I'm saying? I mean, that's how accelerators work. Is how you contain atoms, is electromagnetics. So, like, maybe they don't have charges like this certain altitude, that certain altitude, but what about the ionosphere? In the ionosphere, if you could create an electromagnetic bubble, you might be able to make that vacuum right there. You know what I'm saying? Or like anywhere that there's ions, because ions obviously have charges. I mean, not everything's going to have a negative charge. I mean, a negative or positive charge. Sometimes they have a neutral charge, and you're not really going to be able to push it. And where I started, I mean, something else is like, that's not important. I was going to ask, how did a neutron get into an atom at random and become contained in an atom? Because before, a while back, I was working on other things. I was working on, you know, containment and things like that, in like, you know, a contained explosion. So fusion, fission, fission, fusion, right? Like a heart, a star beats like a heart or whatever. And like so, and it squeezes the atoms back together using electromagnetics and gravity, right? Is how the atoms fall back in. Then they fall back in, they hit the other atoms, and boom, boom, you know, then it creates fission again. Boom, fusion, fission, fusion, fission. And it's just a constantly re-exploding explosion. The atoms get broken apart into their constituent particles. The particles get squeezed back together and become new particles. Some pieces don't. They hit the other particles and cause a new chain reaction. Man, I forgot where I was going with that. But so how does a neutron stay in when the fusion happens? How does in other words, how do I create an atom in a particle accelerator? You know what I mean? Like, say I want to create such and such element. Okay? Now, I through my very narrow stream, and maybe I can narrow it down to fusion, right? So that it squeezes so tight that it fuses. But I mean, I could send electrons in there, choo 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 choo. I could send protons in there, choo choo choo. Okay, so they're gonna try to like stick together, I guess, right? And like maybe I can flood in electrons, then reverse polarity, flood in protons, like and quick enough to sort of build up this layer. Electrons, protons, electrons, protons, electrons, protons, electrons, protons. Then suddenly I got a giant electron ball. You know what I mean? But like, how do I get the neutrally charged neutron to enter in and be held by something in the atom? I don't know how to do it. And we don't either. Like, I mean, the neutron is what causes the chain reaction, because when the particle gets blown apart, the neutron is the one that doesn't get deflected. You know what I'm saying? So when I'm talking about applied cumulative acceleration, the deflection of the charge, the neutron is the one that does not get deflected by the charge, goes in and pokes your atom. Goes right in, boop, and pokes your atom, and it blows apart. You know what I'm saying? So like, we're not going to be able to push out the neutrons, but luckily they're contained in the atoms. So here's the thing. An electromagnetic field in front of our aeroplane, and something that ionizes the air in front of that before pushing out, and it creates a vacuum for us. So there's no air resistance. Maybe that. I just put this stuff out there for other people, you know. I mean, things